Thank you everyone for coming. So it's tough to do 3 p.m. talks. It's afternoon, everybody have a booze or lunch. But I promise you're going to learn very little, but have a lot of fun in my talk. So, who am I first? Right, I'm a red teamer journalistic. Been with them since 2021. Used to deal with kids as a pediatrician before cyber, actually. A couple of pints, then we can talk about the past life. I like acid jazz and math rock. If you like those, you're a cool person. If you don't, you're cool as well.
I had meth rocks.
Ooh. So, just chill. For those who is coming in, I'm going to repeat the disclaimer that you're going to learn very little, but have a lot of fun. It's a war story of application pen tests, which I usually don't get, but for when I do, I have a bit of fun. It's a couple of twists and turns, chill and listen. Also, thank you for the unnamed client who allowed me to talk about this on stage. I retested the app on Monday and they patched everything, unfortunately. So, yeah, let's go. Also, for the chill part, last time I gave a talk at B-Size, it was a red team talk about, how to hack into Microsoft 365. It was super try hard about, what I do day to day. It was red teaming, and it was very stressful because you tend to attract the most try hard crowd, so you want to absolutely nail the tech and everything. So, but this time it's all chill out, right? So the app itself, it's built by people who used to do rocket engineering, aerospace stuff, and they were feeling, requirement management is a lot of work, apparently, like how big the nozzle is, and you design the flow and everything after, bits and pieces of numbers. And if you tweak one number, it changes everything else, and you need to redo the modeling again. So they sort of have this integrated pipeline thing that manages the requirements for, their scientific application. And recently is, a couple of 2-3 years ago, I've been seeing more and more of, the app developers trying to push some sort of Python sandbox in their application, which is very good news for us, or for me at least. But for the scientific types, they tend to not sandbox their Python features very well. This is one of the examples. So apparently for this very application that I'm talking about, the users can link their own GitHub repos, and whatever Python script that's in the repo can be, executed on the app itself. I'm like, okay. Right. So, a bit more background. Users can submit Python and perform calculations, simulation, all that good stuff. The UI or like the endpoint only would return any numeric results. Like if you have 3 variables at the end called var1, var2, var3, and like they come back as 1, 2, and 3, and they will all be displayed on the UI nicely, like there's like code and the value is so on and so forth. But if you have a variable that is called like var4 equals some string, then var4 will be dropped by the app. For example, if you define a variable called like I'm the hacker, and it will be dropped by the application itself. Right. So to a hammer, every elongated object is a nail. So if I see a common, language interpreter, be it, Node.js, Python, PHP, it's, Shelley time, right? So talk about the Shelley. Typically in app tests, getting to the RC is the hard part, but in these sort of like Python sandboxes, it's actually quite rather straightforward. If you do pen testing, AppSec, or if you're a programmer, you would have some sort of favorite way to pass OS commands into the interpreter. For example, for me, I love using os.popen because you type the least number of characters. But you can use subprocess.run, subprocess.popen, something similar, right? So now that the problem at hand is the app itself would only output, numbers, right? Number type, no strings. So I import OS and then I do a popen, echo a number, and then put the standard output as an integer, and then you get, voila, output equals, the number you've echoed. So, well, at this point, I mean, okay, is RCE technically, but am I comfortable slapping a critical, label and calling it a day, get a compliance with friends? I sort of want to do more when you could, get these, sort of juicy bugs, right, in the app. So the first bit of encoding that I want to do, or what I want to actually overcome, is the, integer to string sort of problem, right? Essentially, an interactive or semi-interactive shell is you take command in form of a string, variable length, and then some sort of like data out. The data would be in ASCII, right? So the app, as said, would draw non-number outputs, but within the UI, you can't just do string. For example, if I do os.popen a command and read it directly, it would just, discard the output. So what do? Right? So you need some sort of like first bit of encoding, no pun, right? String to number encoding in high runtime, which means 99.99% is Unix, right? You don't want to do Windows Server and then do it Python sandbox on Windows. Bless you if you want to. So if you do Python, you wouldn't possibly need to handle like Unicode or something like that. Like 99.99% you're dealing with ASCII alone, right? So number and ASCII. So ASCII table to the rescue, right? So those who are not too familiar with it, you could represent each character in an ASCII table as an integer, right, from 0 to 255, or in hex 0x00 to 0xFF, I think. So a number of them are not printable, but the printable ones are all within this integer space that is 0 to 255. Okay. So what I first did, which is complete jank, I warn you, is to concat all the integer representation of the characters into a very long integer. For example, A, which would be decimal 65, B would be decimal 66. You might ask, like the programmers here might ask, why don't you just do hex, right? So they could all be like 2 characters. But then the application, sadly only does, decimal. It doesn't do hex, doesn't do, that stuff. So I have to, be content with, 3 decimals, 3 spaces, or like from 000 to 255, right? And then, again, the 0 at the front would not be displayed because, number don't naturally start with 0 when they're in the natural form. So I have to concat a 0 and then, chop it up in, 3. Oh, too quick. Chop it up in sort of like 2, 3 figures. Right? So the code value here is actually the output for OMI. You can see like 115 is S, 098 is B, 120 is X, so on and so forth. Right? So cool. I could get strings out, right? So when you see SBXU underscore U something. Did a bit of Googling, I found, it's actually the runtime users for AWS Lambda. So a Lambda, for those who are not too familiar, is actually a serverless function sort of implementation for AWS, right? It's not actually the main application itself. It's sort of like a side thing, like an API that it calls. But anyway, popping a side API is good as well. So if you do like the screenshot below is not from my test, it's quoting somebody's blog post. If you do an ID on Lambda, you see SDX user and then number. Like there are hundreds of each SDX users in the Lambda naturally, right? So the front end sadly only would return 20 significant figures of a number of the output. So when you look it up on sort of Python standard specification, the max of type in is this number, which is like 20 digits. And if you divide it by 3, which is each character that I need, you would actually need like only each cycle of importing a script, running the script, decoding it. You're going to get 6 character out. So it's sort of inefficient. Maybe try harder. Maybe getting one cycle. One cycle for 6 bytes, I would be looking at like sort of the rounds of 100 bytes per minute, which defies my expectation as an attacker for good user experience. So I have to try harder, of course. So when sort of life closes one door, look hard for your native networking capabilities. So are there any sort of our band channels? Can I do HTTP and can I do DNS? I've got to mention the I later found out that the Python sandbox actually supports all of the Python standard libraries. So whatever is in standard lib, it's all good. You could pull sockets, you could pull HTTP, and the other standard live goodies. So I spun up a listener on Web Suite Collaborator, listening on HTTP and DNS, and did a little do a URL open on my subdomain on Burp. So then it turned out that the app actually interacted with DNS, but HTTP was no go for some reason. I didn't know yet why. But then it's something. It got all my neuron juice running at that moment. I could pop something potentially here. But then before that, for those who are not too familiar with how one steals data from DNS, I've been talking to some good blogs here regarding how they use text records, but here I use A records instead. Right? Basically, you can think of the vulnerable app making a request to query resolve like juicydata.attackercontroldomain.com, and my name server which resolves that would get the juicy data in the query, save the juicy data in the query log, and then feed the application some garbage data and fuck off. So basically. To POC, that I could get some strength out, right? I did a little bit of 2 bits. Sorry for 2 dots. I chop it up for the block of the sensitive bits. Basically, the first thing was a Python string literal, and the second URL would be just echo some copy that, some string, and I do 2 lookups to sockets.
Just give it all to
Oh, sorry?
You just happen to give it sports with it.
I will talk about it later. Okay, this bit is it's just to POC that in the beginning, right? So that's why I did not run like stuff like Who Am I or like cat the Etsy shadow or whatever to Burp, right? So okay, I could do the echo, I could do the string literal, Postgres, as you said, got my data and sent it to me, okay? And then, well, if it ended here, it was, a good critical finding. I have RCE, I have, string out, I have, extraneous DNS interaction. The client should be happy. But I'm not happy because I still don't have a good user experience yet. Because if you use Burp Suite a lot, it's Java, and Java on Linux is very jank. And you cannot easily, script that unless you write your own extension. You copy and paste is a lot of struggle, and its text is small, and I don't like it. I want more, right? So, yeah. So when I, try to, also when I try to, read more data through this pipe, I would get a strange, sort of, encoding errors, Unicode error, label empty or too long. What the heck was that, right? So I did what a, normal person do. I Googled that, copied that, error and Googled it. And turns out some guy on, Stack Exchange asked the same thing before. He's a programmer, he write his own, sort of, a web application and stuff, and the first subdomain is too long, and then Python threw this strange error. So some guy who had RTFM before told him that the first subdomain cannot be equal or longer than 64 bytes that would be rejected by the DNS protocol. And so during the test, I just took it as is, okay, I'll make it less than 60, and it went through. But afterwards, to prepare for the talk, I actually, read the sort of RFC to see that I myself am RTFM, and actually that person was wrong. It's not 64, it's actually 63. It's super pedantic, but I love bringing it on stage. Anyway, so the RFC actually says the labels must start with letter, end with a letter or digit, and have at least, only letters, digits, and hyphen, and 63 characters or less. Interestingly, right? So, I've been thinking, right? I have poor user experience on Burp, and I need to make something that's, the data is less than 63 bytes per chunk. I need to truncate them up, right? I could only use letters, numbers, hyphens. If I chop stuff up, it might come at different time slot. I cannot rely on the app to make all those queries sequentially and receive those queries sequentially. I need something to order the data by, right? And also I don't want to, as the nice chap said, I don't want to give all my clients' data to Postgres, so I want to run it on my own DNS server instead. Right, and ideally, I should actually have encryption because DNS is supposed to be plain text, and have sessions even. If you run command A, and then the chunk of data coming out would be identified as command A, and then command B would each command would be a little nice session. And then if you're a red teamer in the sort of audience listening, you think, it's actually how sort of Cobalt Strike does it, or like your favorite C2 framework does command and control. Of course, not as janky as how I do it, but it's my principle is actually very similar, right? So I was talking to my people in my team, like who has a good DNS server, which I can spin up quickly and does the job, and ideally I could get the query log in real time in the terminal, so I could just copy the whole thing and type it through grab or whatever and decode the data, right? So some of our developer initially gave me, let me give you my custom-made DNS server in Go. But then 5 minutes later, his laptop didn't work, so he couldn't tell me how to compile the thing with his custom flags. So another red team person told me, you could use Interact SH, which is an interesting tool by the people behind Project Discovery. It's sort of what you do with Burp Suite Collaborator, but it's free and open source, and you can use your own DNS server for it. But basically, so how I implemented, quote unquote, the custom DNS, tunneling protocol, I first encode the whole command output into one string because it's janky, and I basic export encode the entire string because it's ASCII. I could basic export encode. It should end with only it should have only numbers, numbers, hyphen, and letters. And actually, although DNS itself is case agnostic, like uppercase, lowercase DNS would resolve the same, but the server log would still get the uppercase and lowercase as they receive it. So, and then I add a little sequence tag in the beginning, like 0 dot data, 1 dot data, 2 dot data, and I could use my decoding script to decode the whole thing like sequentially, right? So the rest of the good to have features like encryption. I didn't have time. I was lazy. Sessions I didn't have time. Checksum is actually good to have, but again I didn't have time for it. Right. So this is Interact SH. Please let me know if you know how to actually pronounce it. But Interact. Who cares, right? So it's a useful tool if you are starting out with bug bounties and stuff, because Burp Collaborator actually requires 300 quid per year. It's a premium feature, but Interact SH is free. But then you are trusting their server to do their work, so don't put sensitive stuff on their server, right? Run your own server for a couple of dollars a year, which is more secure. So here we can see a screenshot of what it looks like, right? Of course, you can see the subdomain is awesomeblogpost.com, which is completely fake. You can see terminal output of 0 dot, 1 dot, all the chunks that is 60 bytes each, and I could just use the primitive janky method of swiping my mouse through all this text data, copy and paste it into a decoding script, and then get it, do a bit of cut, step, sort, delete, all the Unix good stuff. But this basically the screenshot before was actually the command output for listing /user/bin, because I want to know what sort of tools I have inside of the sandbox, right? So you have like ls, maker, org, cd, all the good stuff there. Curiously, it has curl but no wget. Yeah. So with that done, right, it would have been a very good report at that point already. Like you've owned the app, you've explored data out, you have achieved nirvana of good user experience as an attacker, right? But furthermore, I knew that it was on Lambda, right? So what if this Lambda had an identity, and then you can exploit this identity? So this is sort of like what I usually do on the red teams. When you compromise an application's identity, try to leverage it to move laterally to access what the app can, right? So basically, I try to read the AWS credentials on the app. There's a couple of ways to do it. You can run, the env environment command directly, or you can do as here, reading, search proc/self/environment, and get data out, right? So basically, when I did, this is an actual screenshot from the job, I believe. Yeah. So you can see the session token and a bit of other AWS tokens from the next screenshot as well. Yeah. So AWS region, AWS secret access key ID token, and all that. So then you could log in as the application, right? So at that, it was that point I became the application itself. So to prove that I did, this was done for a blog post, so it's not the client app itself. I did a get caller identity after the login, and prove that I was actually being the Lambda itself. And then, what would you do typically would be to enumerate, to brute force what sort of extra resources on AWS that this identity could access. So basically, like any secrets, any blobs, any users, and all that good stuff. But unfortunately, in the job itself, the identity could only access usership, public IP ranges. So it was not very impactful on that front. So the epilogue was, the client was surprised that we could get outbound DNS like a tool. And they thought the encode as plus exfil story is extremely cool, which I agree is extremely cool. I hope you agree as well. But then the interesting part here was they thought that they blocked all TCP and UDP ports outbound through network security groups. If you don't do AWS, network security groups are basically sort of like AWS firewall, right? So if you block all UDP and all TCP, no DNS should be able to come out, right? Theoretically. So, but could they? So it was that point, and I thought, yes, I might have got a CVE on, AWS Lambda, or did I? Right. So turns out, on, further reading up on how you could actually fully block DNS, there's something called like Route 53 Resolver DNS firewall, right? To block people like me. So if you have the same problem and you sort of want to actually lock down a quote-unquote air-gap cloud machine, you need to actually set this thing up as well, right? I have a blog post on laptop.tech.com. You can take a look at the steps. It turns out I'm like, of course, Jeff has thought of a way to paywall us to, to wrangle us out of, our hard-earned bucks on the cloud bill. Is another thing that you pay a couple couple of quid each month to further secure your, UDP 53, for lack of a better way to put it. But then, yeah, thank you. That's the end of story. Questions? Chill. Right.
You much DNS explored in any other jobs, or is this mostly?
This is actually not my first time to get DNS working, but usually you have better user experience. But it's the restricted sort of interface that forces me to write protocols and stuff. But it's cool to be on to need to be on to be on stage and say you've written protocol. But the fun part is actually in figuring out the limitations, because DNS is not supposed to be for data, right? It's for 255 bytes of an address. That's all. It's sort of like how you would want to repurpose a bike to get on Silverstone, right? So it's that sort of engineering challenge is interesting and gets you to read the actual RFC itself, which again I find it very fun. Not everyone does, but I do find reading RFC is quite fun. Thank you. Enjoy the rest of the day.